All right, so we're going to go over conic sections again, but this time they're not going to be centered at the origin. So we'll say that we're going to translate them to a different center. All right, so you're going to learn to recognize these equations that have been shifted vertically or horizontally, and you're going to write and graph equations of these in the coordinate plane. So here is the equation of a circle again, only it's really the same, because before when I taught this, I gave you this formula sheet, in which case on the formula sheet I have the equations as if, well, I don't have the equation for a circle, which I can put that on there, but it's really just an ellipse right here, with A and B being the same. So you're going to notice now that H and K we're going to use those today. All right, hyperbolas, same thing. Everything's the same, except for we're now not going to be centered at the origin. So let's take a look at an example. Hopefully you guys can recognize equations of ellipses and hyperbolas, like these, for example. The first one is a circle. Now the equation for a circle is x minus h squared plus y minus k squared equals r squared. So you can see r is 3. You can see k is negative 2 here, and h is 1. So it's centered at 1, negative 2, and the radius is 3. So we're going to graph all these. The next one is an ellipse. You can see that for this ellipse, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. So this is a horizontal ellipse with center at 2, 1. Okay, so we're going to do all those. The next one's a hyperbola. All right, if we look at the hyperbola, that has the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. So you can see that that's a hyperbola. Okay, and the last one then is a parabola. This one has the equation x minus h squared equals 4p times y minus k. In which case, this is a parabola that opens upward or downward. In this case, downward because p is negative. But this is a parabola. It's supposed to be that. Okay. Let's take a look at an example of one. This is written not in a form that we recognize. Everything's on one side of the equation and it's equal to 0. We want to find the vertex and focus of the parabola. So let's use our formula sheet for a parabola. Now you'll notice on this one that x is squared and y has an exponent of 1. So if x is squared and y has an exponent of 1, we're looking at this one, a parabola that opens upward or downward. So let's use this. We need to get it, we want to get it into this form. All right, so what I'm going to do is, let me write x squared minus 2x, and let me move the y and the 3 to the other side. So let me write equals, and I'll move the y over so it's negative 4y, and I'll move the 3 over so it's plus 3. So I subtract 4y, add 3. Now what I'm going to do is complete the square on this right here. So I'm going to conveniently add something to both sides that completes this square, makes it a perfect square trinomial. And that thing that I add is always b over 2 squared, if you remember. So I'm going to add b is negative 2 in this case, so it's negative 2 over 2 squared, which is really just 1. Negative 2 over 2 is negative 1. Negative 1 squared is 1. So I'm adding 1 to both sides. Okay? Now, when you factor this, this becomes x minus 1 squared. And on the right side, I have negative 4y plus 4. Next, I would factor out a 4, in which case, I'll factor out a negative 4. In which case, then that gives me y minus 1. And now I have it in standard form if you compare it up here. Now I know it's centered at 1, and k is 1 as well. So it's centered at 1, 1. And I know that this right here equals negative 4 if I compare it to the formula. So basically I know that negative 4 is equal to 4p, which makes p equal to negative 1. So I know p is equal to negative 1. And that's all I need because it asked me to find the vertex which is this point right here, the center, or the vertex, is at 1, 1. And P is negative 1. So if I look at that on the formula sheet, parabolas that open upward or downward, the focal length is P. The focus is at H plus K, I'm sorry, H comma K plus P. Focus is at H comma K plus P. So H is 1. K is 1 as well. So it's 1 plus negative 1, which is 0. So my focus is at 1, 0. So now my vertex is at 1, 1. Right here. My focus is at 1, 0, which is right here. So I know the parabola looks like this. It opens downward, obviously. It looks like that. Okay? Now they asked us for the vertex and focus, so I've got the focus and I've got the vertex. So I'm all set. Now let me, just to show you that, you know, that we've really done this before, let me, from this step right here, let me do it like the way we used to do it when we graph these. Now obviously I want to do it this way because we didn't have a way of finding the focus before. We didn't even talk about the focus of a parabola before. But what we used to do, when we completed the square on this before, we put it in standard form, or we put it in vertex form. So what we did is we subtracted 4 and divided by negative 4, in which case we get, let me switch these two, we get negative 4y plus 4 equals x minus 1 squared. We just switch both sides. Now subtract 4 from both sides and divide by negative 4. And I'll write it like this. Dividing by negative 4, I'll write it like this. What I did is I just divided this by negative 4 and this by negative 4. That's what we did before. Now it's in vertex form. Y equals a x minus h squared plus k. Just to remind you. So we completed the square on parabolas before, but what we did is we put them in vertex form, in which case we then graphed them based on their center and the fact that they open down. But now we have one more piece of information, and that's the focus here. And we also know where the directrix is, according to this formula sheet as well. The directrix is at y equals k minus p, which in this case is the equation y equals 2. X can be anything. Let's try another one then. This is an ellipse, not a parabola. Let's try to put this in our form for an ellipse, which is right here. So we're going to put it into one of these two forms by completing the square. So go ahead and give us a try. All right, so what you would do is you'd group together the x terms and the y terms. So I'm going to make this x squared. I'm going to pull the 6x next to it. I can rearrange this however I want because addition is commutative, so order doesn't matter. I'm going to leave a space and do the y terms as well. So it'll be 4y squared minus 8y. And then I'm going to move the number over to the other side. So all I have left is the 9. So I'll move that over to negative 9. So now I've got the x's right here. I've got the y's right here. And I've got the number over to the other side. Still same equation, just the order is different. Now, what I can do is complete the square on this and on this. So what I'm going to do first, though, is I'm going to make this x squared plus 6x plus blank. I'm going to add something there. Here, I'm going to factor out a 4, in which case I have y squared minus y plus something equals negative 9. So all I did was factor out a 4 from this quantity. Thank you. This is supposed to be 2y.
Oh, no, you're recording. Yeah.
So we're going to add now something to these three terms here. So I need to add something. I'm going to add b over 2 squared, right? Because that's what you add when you complete the square. So in this case, it's 6 over 2, which is 3. So I'm going to add 3 squared. I like to leave it as 3 squared, even though I'm adding 9 to both sides. Make sure you do it to both sides. I'll leave it as 3 squared on this side because this factors now into x plus 3 right here. So I just put this number here, and this number here. And then I need to do this one as well. So I'm going to add b over 2 squared to this one, in which case this is negative 2 over 2, which is just negative 1 squared. So it's negative 1 squared, which is really just 1. But I can't just add 1 to the other side because there's this 4 here. And so when I add 1 to inside of parentheses, what I'm really adding is 4 to the left-hand side. So I need to add 4 to the right-hand side as well, because of the fact that I added 4 to the left side. I've got to add it to the right. All right, so then to simplify this, this becomes x plus 3 squared plus 4 times, this would be y minus 1 squared, if you just factor this perfect square trinomial now. Take here, this, put it here, take this, put it here. Equals, and on the left I have positive 4, because the 9 and the negative 9 cancel, and I have just 4. Now if I divide through by the 4 to get it in standard form, what I have is x plus 3 squared over 2 squared, which I'll leave as 4 for now, plus y minus 1 squared over 1 equals 1. So this is an ellipse. It opens horizontally. A is 2, B is 1. So this is an ellipse that looks like this. A is 2, B is 1, so it's just this little guy right there. And there's my standard form for the ellipse. All right, let's do one more real quick. This is a hyperbola, so we'll put it in standard form. Let's group the y's together. Y squared plus 4y plus something else, and then I'll group the x's, so negative 4x squared plus 24x, and then I'll move the number over to the other side, equals 41. Now, I want to add something else here as well to complete the square. Before I do though, I'm going to factor out a negative 4. If I factor out a negative 4, then this would become negative 6. And now I can add something to both sides, preferably b over 2 squared. B in this case is 4, so 4 over 2 is 2, so it's 2 squared. And I'm adding to both sides, which is really just 4. And then I'm also going to do this one. I'm going to add b over 2 squared, which is negative 3 squared, right here. But that's 9, and 9 times negative 4 gives me negative 36. So I'm really adding negative 36 to both sides. Because 9 times negative 4 is negative 36. I'm really adding negative 36 to the left side. I got to add it to the right side as well. So this becomes y plus 2 squared, this perfect square trinomial, minus 4 times, this becomes x minus 3 squared. And then 41 minus 36 gives me 5 plus 4 is 9. Okay, now I need a 1 here. So I'm going to divide through by 9. In which case, I get y plus 2 squared over 9 minus 4 times x minus 3 squared over 9 equals 1. Now this is kind of a weird one because this 4 here. A is 3, and B in this case is what's underneath here. So I'm going to multiplying by 4 is the same as dividing by 1/4. So I can actually move the 4 to the denominator of this fraction. It might seem weird, but multiplying by 4 is the same as dividing by 1/4. So basically you can look at it as this 4 that was here, I can move to the bottom as 1/4. Because dividing by a 4th is the same as multiplying by 4. So dividing by a reciprocal is the same as multiplying by the number, or all the way around. So this turns into 9/4 in the bottom. And so b is the square root of that, which is 3/2. So now what I can do is, since y is first, if I look at my formula sheet here, when y is first, these ones open up or down. So it opens up or down, and the best way to sketch a graph is to do a is 3, b is 1.5, so that'd be half. So here's 1, 2, half of that. So here's the co-vertices. Here are the vertices. If you make a box like this, and the asymptotes are always the lines that go through the corners of the box. So here's an asymptote here. Here's an asymptote here. I guess I should have done a dotted line, but and so the function looks like this green one. the hyperbola looks like that. Alright, I hope this helps. We'll do a homework out video as well and make more sense of this.